So we want to determine the intervals on which functions are increasing or decreasing. If a function is increasing on a given interval and we have two numbers that are on that interval, identifying them as x sub 1 and x sub 2, then x sub 1 would be less than x sub 2, and that also implies that the value of that function at x sub 1 should be smaller or less than the value of that function at x sub 2. And the same applies when we're discussing decreasing functions. X sub 1 will be less than x sub 2, and it implies that the value of that function at x sub 1 will be greater than the value of the function at x sub 2. Now, visually, we can inspect the behavior of decreasing constant and increasing intervals, which we've looked at previously. In this example, we see the value of the function is decreasing when that function's first derivative is less than 0. We see constant behavior when that first derivative is equal to 0, and then we see an increase in the function when the value of that first derivative is greater than 0. So therefore, we can describe the behavior of the function as increasing, decreasing, or constant based on the first derivative. So we let f be a function that is continuous on any closed interval, and we differentiate that same function along that open interval from a to b, then that first derivative that's greater than 0 tells us that we have an increase in function on that open interval. And also, it should be increasing along that closed interval. The first derivative value of x that is less than 0, then all of those terms should indicate a decreasing function. And if that first derivative equals 0, then we'll have a constant function. Let's look at this example. We want to find the open intervals where f of x equals x cubed minus 3/2 x squared is increasing or decreasing. Now, first, we want to find our first derivative. So we take the first derivative of that given function, we get 3x squared minus 3x. And now we'll identify the critical numbers. We'll set that first derivative function equal to 0 and solve for x. So 3x squared minus 3x equals 0. We factored out 3 and x from both of those terms, and we get x minus 1 in parentheses. So we set both of these factors equal to 0. We'll get x equals 1 or x equals 0. These are our critical numbers. Now, we use our critical numbers. What might be helpful is if you create a number line and place those critical numbers on the number line so you can easily see where your intervals lie. Remember, our critical numbers were 0 and 1. So if I were to place 0 and 1 on a number line, I'll see these intervals much more clearly. So 0 and 1 on a number line, we see we have an interval on the left from negative infinity to 0, an interval in the middle from 0 to 1, and then an interval on the right from 1 to infinity. And see, we've created a chart with 3 columns for each of those 3 intervals, okay? Here's our interval from negative infinity to 0, our interval from 0 to 1, and then our interval from 1 to infinity. After that, we want to find some test values. We're going to test some numbers within each of these 3 intervals. First interval, we're testing -1. If we substitute -1 into that interval and we evaluate that first derivative function when x is equal to -1, we get 6. And since 6 is greater than 0, the behavior of that function from negative infinity to 0 should be increasing. We test a value within that interval from 0 to 1, we test 1/2. And when we calculate the value of that first derivative function at 1/2, we get -3/4. That number is less than 0, therefore, the function will be decreasing between this interval of 0 and 1. And then the last interval, we find a test point. We use 2 for that last interval from 1 to infinity. We substitute 2 back into our first derivative function and we get 6, which is greater than 0. So this time we see an increasing function. Here's an example where we see that function graphically, x cubed minus 3/2 times x squared, and we see that behavior from negative infinity to 0, we see increasing function. From 0 to 1, we see decreasing function. And then from 1 to infinity, we see an increasing function.